Hello guys, welcome to my channel Fundamentals of Engineering. In today's session we are going to see what are the G codes used for CNC programming. As we know, in basic terms, computer numerical control, in which programming is the process used to create program instructions for computers to control a CNC machine and tooling. CNC machine turn a digital file into a sequence of computer instructions, which are then sent to a motorized tool such as mill, router, grinder, or lathe. So CNC programming is not just a difficult task as many things. For beginners, it will be useful if they divide the drawing in some smaller part and start programming them. So G code is a programming language for CNC that instructs machine where and how to move. Most machines speak a different dialect of G code, so the codes vary depending on the type, make and model. So these are the types of machines which we are using for the CNC. So now we are going to see the G codes for FANUC CNC. So there is a little room for error when writing a CNC program. There must be a complete agreement between what a programmer thinks is going to happen and what the machine tool actually does. CNC equipment is expensive and it is powerful enough to destroy itself if programming is improperly. That it said, if a few simple steps are followed consistently, then the changes of making error can be eliminated. So this CNC program we have to write with the help of G code and M code. Now we are going to see what there are different G codes, what is its meaning, what is its purpose of each and different G codes for the FANUC machine that we are going to see. So in this way we are writing the program. So the G001, that is the word, determines the type of operations performed on the machine. So the G code is used to determine which type of operations we have to perform on the machine. So what are these different G codes that we are going to see? So these are the list of G code. Among that we are going to see for the FANUC CNC which are the different G codes which are used. Among that, which is an important one that we are going to see. All others are there in that G code list which we are not included, but at the time of programming that we are going to see. So first is a rapid transfers, in which whenever the tool is required to travel ideally without removing any material, it has to travel at maximum velocity. Therefore, if G00 code is given, the machine is automatically adopting maximum possible velocity of the axis, where we are not doing any machining, just we have to move the ideally tool. So that we have to move with a maximum velocity, then we have to use G00 code. Then next G01, that is linear interpolation. Whenever the tool is required to travel in a straight line path, then G001 is used. So there is a difference. Rapid transfers G00 at a maximum velocity without removing any material, and G01 in a linear path we have to move the tool, then we are using this G01 code. The next is G02 and G03. G02 is for circular interpolation, means movement of the tool in a clockwise, and G03 for circular interpolation, movement of the tool in a counterclockwise direction. So whenever the tool is required to travel in a contour path, then we have to use G02 or G03. Based on the part drawing, for removing the material from the workpiece, we have to move the tool in contour path as shown in figure. The tool is moving in a contour path. So for which direction the tool has to move, For that we can use G02 or G03 for movement of tool in contour path, either clockwise or counterclockwise. For that, we are going to see one example for finding a center of path. Now you will see some questions in technical competitive exams that 2 points coordinates are given. Based on that movement of the tool, we have to find out the center for that curve path. For that, we'll see one example. So the 2 points are given, that movement of the point 1 from the coordinates 5, 5 to the P2, which coordinates will be a 10, 10. For that, we have to find out the center of path. Now based on that, either the movement of a contour path will be the clockwise or counterclockwise. For that, we have to find out the center. So the point P1 at the 5, 5 coordinate. First, we'll see based on the G02, that is a circular interpolation in clockwise direction. There, based on that clockwise movement, we are getting the center of path, that is a 10, 5. So this is based on the clockwise motion. Now the again 2 points P1 which is moving in a counterclockwise direction with to the point 10 P2 10, 10. Then based on G03, that movement of the center that curve path in counterclockwise direction, we are getting the center of that path, that is a 5, 10. So there is a difference how the tool is moving, either in a clockwise direction or counterclockwise direction based on the part drawing. So there we can find out with this movement of the tool, either if which is moving in a counter path, either clockwise or anti-clockwise or counterclockwise, we can find out the center of this path. So for that we have taken this example. Then G04 for dwell, where we are temporary stoppage of tool for specified duration, and G05 for hold, where we are temporary stoppage of tool for unlimited duration. So there is a difference. What is the difference between this G04 and G05? That we are going to see. Now if the code G04 is used with a F followed by any number, here we have used 90, then it indicates that temporary stoppage of tool for that specified duration. So if we use G04 with capital F and followed by any number, then for this you can see 90 means 90 seconds that the tool will be stopped. So G04 for dwell, temporary stoppage for this 90-second duration. And if G05 is used, then the tool will stop until we are not giving any further indication to the tool for movement. So if G05 is used, then it will stop for unlimited duration until we are not giving the next movement for the tool. So there is a difference between G04 and G05. Then G08 for acceleration and G09 for retardation. Whenever the program starts, then the spindle has to start at low velocity and reaches to the required velocity in certain amount of duration. For that, G08 is used for acceleration. When the tool is moving at high velocity, it will be difficult to stop the tool exactly at required location. Therefore, if G09 code is used, whenever the tool is near to the destination, the speed of the tool is automatically reduced. Hence, it is possible to stop at exact point. So, G08 and G09, G08 is used for acceleration, means small value to the larger, and G09 for retardation, maximum possible velocity to the lowest possible velocity, means exactly stopping. So there is a difference. that G08 for acceleration, G09 for retardation. Then G17 is used for XY plane movement, G18 is for XZ plane movement, and G19 is for YZ plane movement. So based on the plane where the movement of the tool is doing the operation, based on that either we have to use G17, G18 or G19. How the movement of the tool in which plane, based on that we have to use these different codes. Then G33 for thread cutting with a constant pitch. In this thread cutting operation we are using this G33 code. Then G34 for thread cutting with the increasing pitch, and G35 at the thread cutting with a decreasing pitch. So G33 is used for thread cutting with a constant pitch, G34 is used for thread cutting with increasing pitch, and G35 is used when thread cutting with a decreasing pitch. Then G41, where the tool radius is moving in a compensation left, there we are using this G41 code. Then G42 is tool radius compensation right. So this G41 and G42 for milling has partially automated through, although it is not completely, since CAM programming has become more common. CAM system let the user program as it using zero diameter cutter. The fundamental of cutter radius compensation still in play, that is the surface produced will be disturbed or distance r away from the cutter center. But programming mindset is different, so the software has various RC mode, CRC mode selections such as computer control, wear, reverse wear. So G41 is used for conventional milling like down milling, and G42 is for conventional milling or as a up milling. So G41 is used when the tool radius is compensation left in the left direction, and G42 when the tool radius is compensation right in the right direction. So G41 is used when the milling of down milling, and G42 in the up milling. Then G70 is English programming. If the values indicating in programs are in terms of inches, it is called as English programming. And G71 metric programming. If the values indicating in programs are in terms of mm, it is called as metric programming. If the values are given in inches, then it is English programming. Then we have to use G70 code. If the values are given in mm, millimeter, then we have to use G71, that is metric programming. As we seen, G08, G09 and G71 are default codes in program. We are using default these codes in program whenever we are writing any types of program for turning, milling, anything. Then next one that is important, that is G90, absolute mode of programming. So this is a component, you can see the dimensions, all the dimension. In this, if each and every movement of tool is indicated with reference to only one single reference point, it is called as absolute mode of programming. So this is a reference position. For this reference position, the tool is set, means all the three axis values are 0, means x0, y0 and z0. That will be the start point. So here you can see one reference point. From these reference points, all other movements of tool is decided. Next, when the tool is moved from at the one location, one will do the operation. Then suppose we want to get back the tool at reference position, then that tool will come to that reference position. So from this, all the distance we are defined, and it can be given for the coordinates of x, y, z. So from this position, reference position, all other positions are given for the reference 1, 2, 3, 4, 5, 6, all others given, and based on that, if you want to call back the tool for the reference position or 0 position, then again tool will come from this reference position. The next one is a G91, that is a incremental mode of programming. If the present position of the tool is taken as a reference point for programming the next position of tool, then it is called as incremental mode of programming. So now first this will be the reference position. When the operation is performing, it will come for the first position, then to the operation it will go for the second position. So there the second position will be the next will be the reference position. So from that position it will take again all other position value for the second, third, fourth, fifth, sixth, means incremental. From what is suggests, the present position of tool is taken as a reference point for programming the next position of tool. So this is the present position is taken for programming the next position, means finding out the next position of tool where it can be moved. When the tool is moved towards second position, then it will be considered as a reference position. If this way, previous position is considered as a reference position for programming for the next position of tool. So if you consider the Indian condition, it is preferable to use absolute mode of programming, because during running a program, any power failure occurs. After restoring the power, it is difficult to locate where the program has been stopped. But if the programming is written in incremental mode, as it is taken previous position as a reference position, but it will be very easy to locate if the program is written with the absolute mode, that only one position will be the reference position. Based on that, all other positions are given in absolute mode of programming. So in our Indian condition, whenever we are writing CNC program, we always use G90, that is absolute mode of programming. So now we have seen all other codes of programming based on the FANUC, and some codes which are remaining that we are going to see at the time of programming for the turning, milling operation based on this FANUC G code. Also we are going to see the M codes which are used for CNC program writing, that we are going to see. Hope you like this. If you like it, please stay connected. Don't forget to subscribe my channel. Click on bell icon to get more notifications. Thank you very much.